In this lesson, we'll be solving linear and quadratic systems by graphing. And we're going to be using a jamboard. And we have on the opening frame a picture of a quadratic function and a linear function graphed on the same coordinate plane. The solutions, if there are any, to a system of equations is where do the two functions intersect? At what x and what y value do the two graphs meet? So I'm going to use my highlighter tool, and I am noticing that there is definitely a point of intersection here, and there's another one down here. So what I can do immediately is go ahead and write the coordinates, the x and the y coordinate of each solution. So I'm looking at -3, -4 over here. So I'm double clicking on my sticky note to edit it. -3, -4, and then I hit save. And over here, I'm looking at 0, 2. Again, double clicking to edit the sticky notes. Now I want to write the system of equations. And let's start with the linear function. We know that if we have a line whose y-intercept is clear and whose slope can be determined, we're going to use y equals mx plus b, right? Where b is the y-intercept, in this case 2, and m is the slope. And slope, remember, can be thought of as rise over run. So up 2 to the right one, right? Up 2 to the right one. So my slope is 2. Now the other curve, the roots are not clear, so I don't want to use factored form. But what is clear are the coordinates of the vertex here. The vertex is at a lattice point, -2, -6. So remember, our vertex form of our quadratic function looks like this: a times the quantity x minus h quantity squared plus k, where h comma k are the coordinates of the vertex. Okay, so I'm looking at -2, -6. So I want to do x minus -2, which I know right away I can say x plus 2. And the k is the y coordinate of my vertex. So that's a -6, so I can say -6. Now a it's the leading coefficient, which when I look at my vertex, and I know the typical quadratic function, the parent function is always from my vertex over 1 unit, and it usually hits right there, up 1 unit, if the leading coefficient is 1. But it's not 1, because look, I'm going to go over 1 unit, and you can see I've stretched it twice as high. So my leading coefficient, is +2. So now we're going to go to the next frame, and it has some information that's good to pay attention to. You can solve systems of linear and quadratic equations graphically and algebraically. Of course, we're focusing on the graphical method in this video. There can be 2 solutions, 1 solution if it hits at 1 point, or no solution if the line and the parabola don't ever intersect. So now what we're going to do is we're going to use some interactive tools here, and we're going to take a look at our system. One of these is linear, the other one is quadratic, and in fact, this one is in factored form. Let's start with our linear function. You know the y-intercept is -2, so I'll drag this over so it has a y-intercept of -2. Now the slope is 1, so I want to tap out of it and just double check that my line is pretty accurate. It's pretty accurate, up 1 over 1, but up here it's a little bit off. So I might just take my line and rotate it very slightly to make it just a tad more accurate. Okay, done that. Now my parabola. My leading coefficient is 1, and the 2 roots are 2 and 4. So I want to drag my parabola over here, and I want to see what would happen if I just find the roots of 2 and 4. Okay, well, this is a root of 2 and 5, so that's not it. Let me lift it up higher. Here's a root of 2 and 4. Ooh, this one looks good. I can see my vertex being down here. My leading coefficient of 1 is over 1 and up 1 from my first lattice point, and I have it. I now believe I have accurately graphed my system. So using my highlighter tool, I'm just going to pay attention to where these graphs intersect. These are going to be the solutions. So I'll go back to my select tool and I'll go ahead and write the coordinates of these solutions. 2, 0. I can change my color if I want to of my Post-it note. And over here I have 5, 3. So for this particular linear quadratic system, there were 2 solutions. -2, 0. Okay. So we've seen examples where there's 2 solutions and 1 solution. Let's check out the next frame. My linear function is going to have a negative slope and a positive y-intercept. So I'll drag it up to 2 for the y-intercept, but then I need to adjust my slope so that it is -1/3. And I'm kind of looking to the right and left to make sure that it's a slope of -1/3. Okay, good. Now my quadratic function, I definitely have to spin it because it's concave down. It's got a negative leading coefficient. This is in factored form. So let's look at the roots of -3 and -5. So I'll focus here my attention on the -5 and just lift it up and down until the function goes through both -5 and -3. That looks good. And now I'm looking at my leading coefficient. -2 means it's stretched vertically twice as much as the parent function, so over 1 down 2. And hey, this is a system where there is no solution. This is an example of a linear quadratic system with no solution. And in other words, there is no x and no y that makes both of these functions true, both of these equations true. There is no x and no y that lies both on the line and the curve.